Hi, I'm Göran. I'm a programming addict. Don't you know that? Hi, Göran. Well, I hope you like programming, because I'm going to talk quite a bit about programming, and it's kind of hard to stop me when I get started about this subject. First, I like to give you just a very brief background of what I do or what my company does. So I'm going to just play this little introductory video for you.
Does. When we created CET Designer, it had to be intuitive and easy to learn because it's all about the user. Software should make things simple, and CET Designer does. You just drag and drop products into 2D and 3D space, building an office as you go. You can place, stretch, and replicate panels, apply materials and electrical, add work surfaces and storage, and everything automatically snaps into place. CET Designer is unique because of how it represents products. There are literally thousands of products on the market, and each product might have 1,000 different variations. With so many products to choose from, specification used to be a problem, but not anymore. Take this chair, for example. It has over 2,000 possible variations, and in CET Designer, we represent it with one symbol. You choose the finishes, the legs, the armrests, and our technology simplifies your work and saves you time. We add product rules to make the software intelligent, which means CET Designer won't let you make mistakes. You're able to designate exactly what you want to appear on the installation drawings, and behind the scenes, the parts and prices are automatically calculated by CET Designer. And an accurate bill of materials is generated with just one click. Everything can be sent straight to the customer for approval and ultimately to the manufacturer for ordering. CET Designer's incredible presentation tools let you design and make changes in collaboration with your customers. You can render to produce photorealistic images, send 3D PDFs so the client can rotate and zoom in on their space, and record fly-through videos to impress your customers. All of this is included in CET Designer. We've created the best all-in-one design and specification solution on the market. I'm Tracy Lanning, Support and Training Manager for Configura. This is the future of space planning.
All right. I hope that gives you some idea of the background where I come from. I started this company together with my father and a close friend in 1990. The core of our business has been programming all the time. So that will be the subject. I'm still, as you might have as an idea, actively programming in the company and developing core software. So this talk I was planning to hold here is called The Art of Programming. And the subtitle is Why is Programming Slow, Expensive, and Results in a Painful Experience for the End Users? So what an unpretentious title, right? The Art of Programming. So let's see where we can get with that. So I'm co-founder of Configura. I still work as, I'm vice president of research and development, but I just see myself as a developer. I work hard with coding all the time. 1998, we got tired of standard development tools, so we started on the journey of doing our own incremental programming language called CM, and I'm going to show you a little bit about that later on. In total, I have something close to 40 years of programming experience, so yeah, I've been doing this for a little while now. So let's have a moment of reflection, though. Why do we program computers?
Make things easier.
Make things easier. Good answer. Any other ideas? Do stuff. Yeah. I like to go to the Hitchhiker's Guide to the Galaxy a lot. You'll notice that. When they talk about a robot, the definition in the Encyclopedia Galactica is a machine that's meant to do the work of man. So it's something that we have to automate things, right? So this means, philosophically, that we should make software that adapts to people and not make people adapt to bad software. You see my point here. And it's fascinating how Yeah, sorry, I was stepping out of line. But what happens in reality, if you look at big projects, you start up and you add code and you keep adding functionality, everything is flowing. So you have like a linear boost to your development curve. But very soon it starts to even out. Turnaround times get slow, bugs turn up, and all these feature requests just rain in on you. So functionality ends up like this. Debug time starts to rise instead of being linear, and the whole system deteriorates in speed and response. And it's like walking in mud in many systems. You press a button in a simple registration application for, like a time management software for a company. You press a button, you have to wait for 3 seconds. 3 seconds in the 4 gigahertz computer era is an eternity, right? It's impossible to waste that unless you totally misuse and miswrite the code. So let's think about what sort of defines, what can we create with software? What is going to define the limits of what we do with software? And I have sort of boiled this down to a 3-dimensional idea. We need programmers. We don't have any machines that can do this yet. I don't believe in AI. AI is at a level of 0 IQ, and that doesn't matter if that grows exponentially. So we'll see, it might change in the future, but right now we have no AI. It's just automated programs or better or smarter programs, but they're not smart in the sense of people that can create software. So we need brain power, and the smarter you are, the better you can do it, right? And here you have programming language, because how do we program? Yeah, we have to take our thoughts and boil them down into precise statements. So precision in language expression is what gives us this. So a better language will get us further. And on the bottom axis, we have process. And process here means actually the actual act of doing a change in your program and turning it around and seeing a result. So it's nothing to do with Scrum or planning a group to work or anything like this. It's just the simple act of making changes in your program and seeing results. So let's take a look at programmers. That's us, right? So programmers are smart. That's why they're drawn to this area, because it's not easy. It's definitely not easy. So high IQ, and you get to train your mind every day. So it's very stimulating. It's like an athlete that can train his muscles and grow stronger and stronger. You become better every day. You should strive for excellence, right? Every day to become a better programmer, to do something better, to improve. Well, this means that with these very smart minds, they're also very good at taking in complexity. And you see the consequence is hard to understand when it gets complex. So it easily just boils out and becomes very complicated. And then in the end, when you've created this complex mess, you're very proud when you solve this strange bug or when you create an even stranger function up there. This little picture down here is Russian dolls. You have a big doll and you pull it out and there's a smaller one inside. And this is a typical effect of a programmer's bright mind. He's working on a problem and then he sees this little smaller problem inside there. Maybe the first task is big and then he goes into maybe the allocator function I need to make this more efficient, the custom allocator. And he digs into the custom allocator. I can improve this and make that faster. Oh, but if I do an automated translation of that, then it can be, and you go again into an even smaller problem. You can keep going. And in the end, no one cares about what you're trying to solve because it has no real effect on the world. But it's very fascinating in your mind. So programmers like to write complex code. It looks like this. This is an extract from our system. It's a very messy piece with a lot of ifs and fors. And how can we be sure that we covered all cases and run all this code? Well, it's just a prototype of a clutch or something. And that's where you start. I'm going into what I call here the value chain of programming. So you start to create something. You have to start somewhere. So, because if you don't know exactly what you're going to write out, and no one does, even with a lot of experience, you can't do it perfectly from the start. So you have to start with this. But then you need to refine it. Yeah, you can at least name it. This one is called reload and build. So we got a function. We got a name on it. So what can we see clearly? It has a name with two parts, right? Reload and build. So could we make this better? Yeah, there's clearly a reload part and a build part. So why don't we take this apart and it would be a two-liner? And then we could reuse those functions depending on the context. Called what? Yeah, refactoring, right? So we're refining the program, making it more reusable. We keep going up the value chain, and we spend time on looking more on a reflective side overall to measure on the code, to tweak it, to tune it, to refine it. Maybe optimization is in place to do at this stage. We generalize, so maybe we need some extend methods, some virtual methods in there, so someone in the future can use this in a context that we did not think out from the start. We maybe go an abstract if we make sort of an instanceable system out of it, so it can be reused in many more contexts. We go even further, we modularize. So what does that mean? We minimize the dependencies. So that again makes it more useful in other contexts, because it's very, very typical if you see in any type of software out there that you pull in the world. You want to say hello world, but it becomes a 1 gigabyte exe file, because everything is used instantly. So what is the absolute top value you can create in software? I call it DSL, it's domain-specific language, but I really don't like D, because I think refining the language is the highest art we can do as programmers. That means programming the programming language itself to do a better job at solving the problem domain we are in or at. Look at mathematics as a parallel. What is mathematics? It's an extremely compact, perfectly orthogonal notation, which is extremely precise to express very advanced concepts, right? So why is it so super compact and refined? Why does it need to be that? Because we do symbolic computation with it, right? In our minds. We are both the processor and sort of the problem solver using this. So in math, it just has to be that. But isn't it fascinating that programming languages coming from the math domain and inherits a lot of that suddenly froze up at some stage, and we stopped refining them? Well, yeah, they are refined, but the process is agonizingly slow. What do you do if you want to improve C++? If there's something you need that isn't there, that's going to make a big difference to your program. You're going to write 1 million lines of code. You're going to write this at least 10,000 times. So the impact is enormous. It's almost like it can't be done in that language unless you can support this extra thing that does. And there's no way to fudge it with a macro or with an instanceable type or anything like that. So you really need a change to the language. So what is the process you have to go through? You can post in the forums, right, and start to argue for the feature. And then hopefully Strustrup picks it up. And then maybe in 2017 or 19, there is a new feature in the language. When we developed CM, so around 2000, I think we did something we call inherit constructors. So you have a class, you have a couple of constructors, you subclass that. In C++, you had to repeat the constructors before. But we just, by default, inherit them. If you add a constructor, maybe that's the only one you want. But if you say inherit, then you get the ones from your superclass as well. This is very nice. And then a number of years later, I don't remember exactly when, this was introduced into C++. I was not aware of it. We just accidentally discovered that that had happened. So that was sort of fascinating. So, but looking at the programming value chain, though, my argument here is that you start with a prototype, it has very little value, or even negative value. Because within a bunch of prototyped code, you lose the programmer, or even just 2 weeks later, he can't do anything with it because it's a mess. A complex mess, and it doesn't matter if you have 200 IQ, you can't really work with that type of code. You have to refine it. And the more you go up on this value chain, it's really like, this is just my idea, my hypothesis, it's an exponential value. It's not just a linear improvement. So let's look at what programmers really do. I think most of the programmers I know, they spend all their time here, adding. Oh, I came up with this new idea. We can have this cool feature with if you move the mouse this way, we get this. And then you start hacking up a new module to support that. So you're adding, right? And you get the bug, and you need to fix that bug. So you go into the code, and, well, I can if this case, and then specially treat that and return. So you just keep adding. Do you ever go over the code and clean it up? Do you clean up the code before you do the fix? Do you minimize, tune, optimize? Do you think about what happens if I throw out 10,000 objects? Going up the value chain here is less and less. And if you look at modularizing, for example, the tools support we have for that is usually, well, I'm not aware of any good tools, really. If you start to write up a program, you write a class just in the middle of the program, it's going to use everything in the surrounding context, right? And then well, I need to load a DVG drawing from AutoCAD. So you just use the format DVG, and bam, you get that too. And then suddenly everything starts to depend on everything. And it's enormously difficult to go backwards then to try to extract this and make it independent of the surroundings where you created it. So modularization is enormously hard unless you do it from the start. Yeah, maybe we can create tools here that assist human beings to understand where the complex cuts has to be done. But it's not an easy process to do that way. So I think only master programmers, the best out there, even think about this. And how often do you do DSL? Do you ever even think about changing the language you're working with? Well, I can't even start up a project without thinking about it. The first thing I look at, when I wrote the compiler is written in C++. The first thing I did was modify the current preprocessor, which is a much more advanced version where I can do for loops and things that looks nice, so I can take a code argument with open-close brace and expand that. So I started working on the preprocessor. I added stuff like create. So I added some keywords so I didn't have to create the .h file. I don't like to do the double bookkeeping. So I did an automated procedure with the preprocess to do that for me. So I started working on this instead of working in C++. I didn't like the language enough. Then it's a tool. You use it for what it is. So for me, building a language to fit the problem is the first thing. And the more I can do that, the less I have to write. Because I'm creating a language that's fit for the problem. So if you ask programmers, everyone agrees, right, that we should refactor and refine and write beautiful code. Why don't you do it? Everyone will answer, or every time I ask this question, I don't have time. So why is that? Yeah, we add, we create a complex mess, and we debug. That's what we do. So of course we don't have time. So we created this situation for ourselves. So, programming languages then. It's hard to see this, isn't it? This says C++, for int I equals 0, I is less than count I++. What's wrong with for here? Everyone typed that 1,000 times if they've done any C++. I wrote on the internet someone who wrote, if I got a dime for every time I wrote that, I would be rich. But is this really a for? Yeah, it has an init statement. You create a variable initialized to 0, and then it has a condition. But what is that condition? It should do the body out here as long as. So it's a while, isn't it? It's really a while. So this is just heritage. It's inherited from like 1970 or something, when the best guys in the world, Kearney and Ritchie, created Unix and C. I have all my admiration for them, but why do we still carry this with us? Or at least we could have a compilation flag to let's use a modern version of this. So that's what I did in CM. I call it while for what it is, and I allow it to have 1 argument, 2 arguments, or 3 arguments. This is so archaic to just have one thing. And the whole thing, as soon as you do this, that you take a concept that's while and you call it for, your mind is so fast in adapting, so that's not the problem itself. But you are on a conceptual slide. And this slide is really dangerous, because when you're starting to build big systems, I'm talking millions of lines of code, that conceptual slide will slide you into it will ditch the project, more or less. it's almost better to call a function foo and bar than call it almost the right thing, because almost right, that fools you into thinking that it actually does that, and it does not. So more on a little more details here on conservative design. Here is, wasn't this inherited to Java? It says switch I, case 3 colon, case 4 colon, and break. And then what is the default? The default is a fall through. So here is result equals 0, and then there's a sign result equals 42. Yeah, right. Hitchhiker's Guide, right? So then we did not. Yeah, we have to trust them that we got a 0 through. So maybe the programmer had a semicolon here. It would be uninitialized. So it's a source of errors. This is a known common source of errors. So what I did in CM was to say switch I, and you can have enumerated cases like case 3, 4, or 3.5, whatever, you know. And then result equals 42. So there's a statement here. The break is automatic. And if you need double statements, you do a block. Very, very easy. And the default that's generated by the system is throw can't happen exception. So the bug, you forgot that case. So I want the dynamic fault for that. So in this case, to make the code the same, I wrote default colon semicolon to give it an empty statement fall through. So it's a clear fall through if the cases did not match. So we're switching the default of the default around and get a better language that's less bug prone. These are just tiny examples of improvements that you can keep doing in any programming language. I think we probably have a list of over 100, and 100 tiny changes adds up to a lot. It's not just a small tweak to what you know. This is C++ again. Printf test took %.3 fms, milliseconds, a % big S, etc. And then you have to divide t by 1,000 to remember it was milliseconds, and then your 2s functions that may crash because they're methods. So there's no way of making a method safe for null, right? So then you would have to a question mark every time colon null, which is enormously tiresome, because you know from the start that 2s should never crash. Just, it's toString, you know, give me a string for this object. I want to print it. So this is CM, PLN, maybe too long, print line. This is what we do all the time when we program. This is the most common statement that's ever written, right? Because it's the most common debugging tool, and also I think the most important one. I have a lecture that over 30 different debugging methods, if you don't believe me, that I know a little bit about debugging, but PLN is still the most important one to understand the program. And it prints this stuff, and you get the microseconds and milliseconds here because it has a time type. So it already understands what the time span is. And there is the hashtag A, and then you get the string A equals N3. And then semicolon means comma space. So we type this so many times, and we want clear traces. How many trace lines do the average programmer read every day? I would say thousands. If you don't make clear traces, your mind will become tired from just interpreting your own traces, or even worse, confused. You mess up the trace, and if you're confused by it, you draw the wrong conclusions, and you're working on solving the problem the wrong way. So get clear traces. Every possible way. I'll get back to this. I'll show you live instead. So what I think about most current programming languages is that they are quite limited in what you really need. They're not, many languages are very clumsy for common constructs. I don't know if they fixed that in Java. I hear they fixed it in NetBeans, for example. You can have a command key for doing the console.writeLine, you know, all this big form that you have to write for doing a PLN. Because to my knowledge, there's no way to make that shorter in Java. There's no preprocessor. So you can't even cheat around with the preprocess to make it shorter. And for me, that leaves me, I don't want to do Java. Sorry. So even if you have your NetBeans to write that out for you, it's going to be all that text for your brain to process. Yeah, you see that as a big picture, sure. I mean, you get used to it, but you know, make it short, make it more distinct, give it a syntax color to make sure your mind just catches it. So you can just look at the code from a distance. And this ability to adapt the language to your needs is so important. And many languages also, like C and C++, force you to do double bookkeeping. So you have to type up things in many places. You have to register a file in the make file. You have to do your .h file. So for every change, it's a little messing around. And even worse, with C++ still they're still stubborn about the order dependency, especially if you do a lot of inlining. It's enormously complicated, and computers are enormously good at resolving those. So I don't see any reason to stay with that. I just really can't understand why they kept that, or why there isn't, again, a flag that you could enable a more modern interpretation of the language. Because compatibility, I have all respect for that. There's a lot of code written in C++ out there, and we need to stay compatible. So do your own compiler. So, because if you look out there, also the speed of the language is quite important. The type of applications I work with are highly interactive. So if I start with a language that's interpreted, the end result doesn't get snappy enough. I want instant, and I want 50, 60, or even, now you even want 100 hertz response, because you're going VR. And I want to edit in VR, not just view a pre-generated scene. That's boring. So, or they're kind of academic Lisp or functional systems that are not very fully applicable to real life development. Maybe some Lisper in here will disagree, but I love Lisp in many, many ways. I think it's one of the smartest languages ever. But you don't get a proper surface syntax, and it means you're editing syntax trees. You're not editing code. And then you have this development cycle that comes into process, of course. It's slow when the project grows. Typically what you saw before on my video was like around 5-6 million lines of code running there. We can make a change in the running program in 100 milliseconds in the usual case. Depends on the dependencies of the change, of course. If I need to recompile 100 functions, it's going to take a full second maybe. But it's not a long process, and you don't have to restart your context. So, but build your own language, yeah? It's kind of taboo, right? That's not something you do. That's something other people do. I just find it fascinating that this area has become like offline and taken care of by the big companies, more or less. And we just have to accept what they feed us. So, yeah, I'll show you a little CM in a moment. So what is the programming process? Well, people suggest many ways of programming. When I was a kid, they argued that you should draw up flowcharts. Of course, when you code assembler, maybe it makes sense. You draw a flowchart on paper, but it is 2017 right now, so things has moved a little. I don't do that, even if I sit and hack out assembler or code generation. So, and documentation is a very popular thing. That if you just document, all problems will go away. I think it almost doesn't solve anything, or even worse. How many times have you seen any old software and read comments in the code? What happens to that comment? You shouldn't be allowed to write a comment without adding a date. You know why? Because it's best before. And it's more like milk, it's days. If you have a dynamic software and you're moving fast, if I work with a system 200,000 lines, then I will look at some piece of code and say, no, this is not nice, and I will have to do a replacement. So I use Emacs power to do a query replace throughout the whole system, and maybe I have a second or a sub-second to look at the change, or maybe I even program up a macro to do, because I'm going to do 100 edits or even 1,000 in the worst case. Something in between there. So that's like a horizontal slice change through the software. You don't have time to read all the details of those 100 places. And then you do another one, and you do another one, and you've done 10 of them, you've done your change. It works. Wonderful. I submit. No, I failed. I revert. I kick everything back, and I try again, because I did some mistake. No, I didn't do the mistake this time. Now it works. So that's a horizontal slice through the system, and I move the system from this shape to another shape. And now it's up and running, and it looks much better. I'm happy with it. So that type of change will really make and render comments in the code that talks about what the code does. kind of useless very quickly. And then they even become misinformation. So you read the comment and you look at the code and say, this comment has nothing to do whatsoever what's in this function. It's surprisingly often that happens. So yeah, I like comments, but use comments for the right thing. Talk about design ideas, but even they have a best before. If you change enough, it's going to do best before on that. So what do you do if you can't write commentary that explains the software? You have to do the value chain, and especially the language thing. When you can write down the software in such a tight form that it's readable as 1, 2, 3-liners, then it's understandable. And if it's not, then you need to educate yourself on the problem domain rather than the code. Because if you've never been into parsing, for example, you have no idea how to go about the subject. So you need to understand how that type of problem is solved. Then you can read the code and understand it. So what do you do with the process? Yeah, there's only one thing. You have to have an incremental process. There is no discussion anymore. This is 2017. It's not 1990. We started this company on 25 megahertz Sun Spark stations. It was not on PCs. So 25 megahertz. But it was a 32-bit computer. It had Unix running. It had X Windows. We could do simple outline animations interactively. We could get desks to snap together like you saw, but only in 2D. And when you dropped them, we filled it in. So it was revolutionary, much more beautiful than AutoCAD was at the time, which is still the same, right? But we, very, very quickly, the work slowed down. So we went from a 30-second build and run cycle to 60. 60 seconds, and then we invested in a $30,000 machine to stay on 60 for a while. And this isn't good. This is not what I want to do. You sit there and you so carefully type up your code before you dare to compile. And then now I commit. And you wait and you wait and you wait for it to start. Well, at least we automated this in Emacs with the Alt-P. We would do make, and when make was done, it would execute, so the program would pop up, so I could at least rest and think about something else. Because 60 seconds is beyond my attention span, I lose interest. And I have to wait to get an answer to be able to continue with what I'm doing. So this is so different process-wise than an incremental system. I'll show you in a moment. Fastest possible machines do not save money on cheap machines. And big screens, of course. You can use as much screen space as you can see, which is 180 degrees. Do not go cheap on networks or on servers either. Everything should be the fastest possible, because if you do, all these little waiting times that otherwise add up and eat up the programmer's time, they will instead be productive time. So you get the payback very, very fast. Otherwise, it's not a serious programming project. So, of course, the programming language is very much integrate. It's hard to separate a programming language from the culture around it. And there is a culture of libraries, of course. There's also a culture of tools that support working in the language. And another thing we did, because it's similar in Lisp that way, that we have the compiler online all the time when we sit and work, so we can ask, we can query. So we do our Alt-I command in Emacs, and it will jump to the definition of that thing. Or if you're on a definition, you can ask where is it used. So navigation is fundamentally part of my programming process without me lifting my fingers or leaving Emacs in any way. So it's instant, it's there, it's queryable. So what can we do? Yeah, we need enlightened programmers that fight complexity and fight speed, that don't just write quadratic algorithms that eat up even the time of a 4 gigahertz computer and all the memory that you have on today's machines. It's just such enormous resources, even on a phone, right? And we need we need the ultimate programming language. I don't know, it seems like the title got lost, but I was proposing that we should talk about the ultimate programming language to, the one to rule them all. And we should go for the superconductor process. So this is a picture from the same book, The Hitchhiker's Guide. So this is Deep Thought. You know the story? Yeah. So the philosophers come here after a couple of million years because he's supposed to answer what's the answer to life, the universe, and everything. The ultimate question. So they come there to listen. So, and the funny thing, in the aftermath of the answer, because he says 42, of course, but then he goes on. But then, I mean, they realize then that, you know, we don't understand the answer because we didn't make the question precise enough. So then he goes on with, I cannot compute that, but I can design a new computer that can do that. But it's very poetically expressed, like, whose mere parameters I'm unworthy to design. And I feel the same thing about this new super ultimate computer programming language, that I'm definitely unworthy. But I think people and resources today has gone to the point where we could make such a different language. We would start with first I was thinking, you know, that there are different semantics in languages. In a refrigerator, you need a state machine. So you don't even need a stack. You don't even need a call stack. But then you go to call stack, and then you go to dynamic memory allocation, then you go to garbage collection, you go to scheme, you have a dynamic dynamic stack, so you can do continuations, etc. There are all these variations. So I thought I should pre-configure the runtime and then start incrementally working on the program. But come on, wait. If I have an incremental compiler, or just this front end in the executable that can sort of take compiled code and translate it into machine code and run, then I can load the semantics. So I can even change or complement or run parallels in there. So even the runtime would be configurable in the running process. And then you have an incremental compiler running over a line. What that means, so you're not in the same process. You may not even be on the same machine. You might even be in an installation at the user and be able to change the code. Or you're working on a cross-platform project like a mobile phone. You would still be able to do that. And the language itself would be enormously bare bones in the bottom, but then you load the actual syntax exactly like you load any library. There's no difference, because it's just code. And let's pop out. I'll get back to the ending. I'll get to my favorite place in the life, Emacs. Can you see this? Yeah. Is it too small? I can go up. Everyone? It just gets a little, it almost gets too big, you know, if you do 18 points. I'll try 18 points to see what happens. So, this is a startup CM. It's just no special program. We type up a variable and say it has a value 3. I can reload, so it's in there. I do this PLN thing, right? So we're looking at the value. You see that? A equals 3. I type PLN hashtag A for it. Well, not very fascinating. Let's look at one of these improvement cases. If you want to have a boxed value, a value lives on the stack, right? An int value, but an int object lives on the heap. So we need sometimes to have maybe a mixed array of ints and doubles, for example. So you need to be able to box them into objects. And I do this by changing the first letter, so then it's a class A. So regularly in C++ or similar languages, you would do this, right? So it runs. It actually has, you can see that it's a box now because it has a class. If I asked class on the int value, it wouldn't have anything because we're still a statically typed language. So, but then if you look at the create, I can navigate to them. Let's navigate instead. So we jump to int A here. So I did that alt I thing I was talking about. You see, it's a class. And if you change that to value, it will live on the stack instead. So class says already that it lives on the heap. Right? And then I don't need to type new. So I can take that out. So, but if we did that, why do we need to repeat int 2 times? I take that out. I run again. Then, of course, the system has something called automatic boxing, which is no magic at all. I think they all have that nowadays, so I can just do that. So it will be the same thing. But you see, you can have an argument list go to a constructor immediately on the type statement line, which is highly convenient. If you take this further, say, if we start it like this, object, we have a function which got a parameter z. We don't really know what that is. Well, a is fine. And then we want to dig out the int value again. So then we would need to do a cast. First, maybe we have our object a dot. So a cast here, caps lock, I hate caps lock. So that's a cast, you know. This is the typical cast, right, in these languages. But I just tend up, you know, it's very common that you want to continue accessing with a dot or something, and then you have to go around this process. I don't really like that syntax. It's not very beautiful. And I tend to think about what am I going to work on? Yeah, I'm going to work on A. Yeah, what do I want to do? Yeah, I want to turn it into an int, and I want to access the value. So now I'm down to a value, and we can print that. So now it's Z is on the stack. So let's make it a little shorter. We introduce an unboxing syntax. But there's still two ints again, right? So let's do the conditional assign. So if it is an int, give me the int field. But if it's not, I'm going to get the default. Now it's a double, right? So I get 0. Yeah, we can change the default and say -1. So I have full control over the unboxing process. I don't know if you're familiar with this from Java, for example. I know that they moved that into the dynamic domain. So that means you automatically get unboxing. You don't have to type anything. So it's even easier. But what happens? Yeah, say you have a function that takes object, and you give it an int. It works. It runs, right? And you change that function without seeing the call to taking in a double. And then you get an exception. So you moved it in, the fault find, the error finding, you moved that into the dynamic domain. And I don't think that's a good fit for a statically typed language. But anyone can have their ideas about it. The cool thing with this happens when you want to save your code up. So you only pl if it is. So it didn't print, right? Now it's an int. Now it prints. So if you type this up for everything you have to type up in C++, because you have to introduce several variables to do it before you have your Z. So this is kind of a new development to introduce. So now let's have some even more fun. We are x equals 3, I equals 4, and we pln. So nice, huh? And we pln again. Very fantastic program. And we do an x swap. xy. There's no x swap. I'm just making it up. And I typed a colon there just to do crazy language design for fun. So syntax error. Yeah, I understand. Public statement. X swap. First, we need an expression. And then we need a colon. And then another expression. And then there is a semicolon to end the statement. So if we match this syntax that I typed up, it's a BNF expression, so it can extend the parser. Well, let's just return an empty statement, null. And now we compile and we can run. But nothing happens. Of course nothing happens. There's an empty statement there in place of x swap. So now we need to do some code. So let's examine what we do have. So I'm asking for what I have. And I'll even do this. I'll just do a reload instead of a rerun, a reload and run. Run runs the statements that are unbound to any function. So you see, this pln here was still executed, even though I just reloaded, because it's a compile time function that's an expansion function that I'm asking. And I'm getting the variable name, x, in A. I'm getting its type, it's an int. I'm getting its class. It's an expression. Yeah, fine. It's just AST expression. So let's return a statement. it's going to be something like, we need a type. Well, we'll just type in A there, and then a temp T is enough. A again, and we can assign over A with B, and then B equals temp, right? Did I get it right? Hope so. Syntax error, semicolon. So, see what happens? So now at compile time, we run this expansion code, which creates a templatized statement piece of syntax tree. It gets re-injected into that place. So exactly like we typed it, but with all these parameters in place. And when it runs, it actually does exactly what we wanted to. If you notice that, now I could, for example, say if a.type equals int, and have a specialized version of this and return something else, or produce an error. So if you compare to, for example, hashtag if, isn't that interesting that of course this was, again, that old language design from the old ages, but you have one if that you have to type one way first for the preprocessor, and then exactly the same concept, but you have to type it another way. So you have to learn two ways, and in my world, there's no real reason for it. So here I'm using the same language to produce the modifications to what I want to do. So, was it clear? Was it cool? So we can take a look at that. CM syntax. I'll just do a PLN on S, and we return S instead. So here is the expansion on the syntax tree prints, and it even has an allocated stack slot for that. But it's just debug output. So let me just finish up my. So the ultimate programming language should at least have that level of incrementality and flexibility, but hopefully a lot more, because the CM language, yeah, it can be generally applied to more things than Configura's problems, but I never had any intention of using it outside Configura. It was specifically tailored to our needs, but of course it's full of general functionality as well. So this is a drawing that I got made by an internal artist. This is a mountain of bad software. So if we don't follow the principles I'm talking about, this is what you get. You have all these spider webs and all the poor little spider programmers trying to make this not fall. And here you have the feature trucks coming in from all your customers, and they're just pouring in over the edge. But if you follow the principles, this is where you get. You can build high. You can build a great project, and it will run, and you will go home and you feel good about it. I don't want to go home and feel bad about my software and force people to use something that's either buggy or slow or whatever. I really want to be proud of what I'm doing. Okay, if you haven't understood it, programming is my passion, so I took the liberty to write this little piece up. It's inspired by The Art of War. It's the start of Art of War by Sun Tzu. Programming is a matter of vital importance for mankind, the province of life or death, the road to survival or ruin. It is mandatory that it be thoroughly studied. So, that was all.